Measurement is a fundamental process in science that allows us to quantify and compare physical properties. Every measurement consists of three basic parts: a numerical value, which is the actual measured quantity, a unit, which is the standard used for comparison, and the one that a lot of people forget about, an estimate of the uncertainty, meaning an indication of how precise the measurement is. Let's say you want to measure a person's height. If I say that their height is 1.75, that's a numerical value, but it is totally meaningless without a unit. 1.75 what? Feet? We're talking about an infant. Meters? That could be an adult. Light years? Something is either very wrong with your person or your measurement, and I suggest you go remeasure and double check that result. The uncertainty depends on the instrument that you're using. The uncertainty of a measurement generally falls into three different categories. If the instrument has gradations, like a measuring tape, a glass pipette, or a glass thermometer, if the instrument has a digital readout, or if you are counting objects. For an instrument with gradations, estimate one more digit than there are gradations and assume that that last digit is plus or minus 1. Let's say you have a meter stick with a line or gradation every 10 centimeters. You measure a person's height, and you can see that it's about halfway between 170 and 180 centimeters. Go ahead and estimate one more digit. So we're going to estimate and record 175 centimeters. Maybe your estimate was a little bit different than mine, so that last digit's a little bit different. That's okay, it's an estimate. But since we estimated that last digit, we are going to assume that it's plus or minus 1. So 175 plus or minus 1 centimeters means that the true value is in the range of 174 to 176 centimeters. Now let's measure this same height again, but with a meter stick that has a line every centimeter. We can see that the height is just a little bit over 175 centimeters. But the rule about uncertainty is the same. Estimate one more digit, then there are gradations. So I'm going to record 175.2 plus or minus 0.1 centimeters. This means that the true value is 175.1 to 175.3 centimeters. For an instrument with a digital readout, the rule is a little bit different. Record the number as is, and assume that that last digit is plus or minus 1, unless you're told otherwise. There's nothing for you to base an extra estimated digit on, so don't try. Let's look at a digital clock. Say you glance up once and it says 12 o'clock. A little bit of time passes and then it reads 12:05. How much time has passed? 5 minutes? Great. Yes, we can do math. But let's consider the absolute least and the absolute most amount of time that could have passed. We can't see the seconds on this clock, let alone fractions of a second. What if it was 12 o'clock and 59.99 seconds, and then 12:05 and 0.00 seconds? That's just slightly more than 4 minutes. Or the other extreme, what if it was 12 o'clock and 0.00 seconds, and then 12:05 and 59.99 seconds? That's almost 6 minutes. The time that's passed is 4 to 6 minutes. So that's 5 plus or minus 1 minutes. If an analytical balance reads 49.7167 grams, assume the uncertainty in that last digit. So 49.7166 to 49.7168 grams. Some instruments specifically give you different uncertainty, and you should use that uncertainty if that's the case. Otherwise, assume plus or minus 1 for that last digit. And our third category is counting objects. Let's say you have 6 eggs in a carton. Is it really possible that you could have 5 or 7? No, it's 6. There is no uncertainty here. So we could word that is there is no uncertainty if we are counting objects, or the uncertainty is 0, but think of it as 6 plus or minus 0 eggs. Let's check comprehension. If you've ever broken a beaker in lab, click that like button. We've all been there. Thanks for watching Chemistry in a Nutshell.